Hello, and welcome to The Confident Commit, the podcast for anyone who wants to join the conversation on how to deliver software better and faster.
If you're looking to build a trusted ship, tune in, let's confidently commit.
I'm your host, Rob Zuber, CTO of CircleCI, the industry leader for all things CI and CD. And today I'm joined by Luis Ceze, CEO at OctoAI, and professor of computer science at the University of Washington. Is it professor, former professor? We can start there. Like, you are a professor and a CEO of a company. That's hard for people to understand. So first of all, welcome. So excited to have you. Probably maybe not the most interesting detail that we'll dive into, but let's get it out of the way first. Are you actively a professor? Because I think it'll help people understand your perspective. Yeah.
The quick history there. Yeah. So thanks for having me on the show, Rob. I've always really enjoyed our live conversations. So it's kind of fun to share this with an audience here. So I have an academic background. So I came to the US 20 something years ago to join IBM Research, worked on the Blue Gene project where I did a hardware, software, within compilers, for high performance linear algebra. Now came back to a lot of relevance in the AI days today. And then did PhD in computer architecture and parallel computing. And then joined University of Washington on the faculty of the computer science department here 17 years ago. The majority of my research there has been the intersection of computer systems, meaning how to make computers faster, better, easier to program, cheaper, and so on, and how to do that in a way that enables new applications. And AI machine learning workloads have been the focus of my research pretty much the entire time I've been here. And about 10 years ago or so, started doing work on how to make AI and ML more portable, higher performance in a way that we use machine learning to optimize machine learning codes. That was the genesis of the Apache TVM machine learning compiler project that then led to founding OctoML. That was OctoML then, from the University of Washington with graduating PhD students there and collaborators from industry. So we are a university spin-off. So I am really a real professor, reformed, turned into CEO. I still have an appointment at UW. And I've been on significant leave because OctoAI is a significant chunk of my cognitive cycles in my life, and I love what I'm doing here. And then I'm focusing it now. Still keeping close ties with the academic community, especially in AI systems, still advising PhD students and so on. So.
Wow. Well, that is a lot to take on. And I imagine it gives you a lot of sort of breadth and perspective. I would say, we were joking about this overnight, success of AI that has been such a long time coming. But AI is definitely having a moment, right? Like, we've, as a society, certainly as a community of software developers, have really, I would say, generative AI has made it much clearer what the potential is, and then has expanded everyone's perspective, and then we're going pursuing other things. So a great place, your right place, right time to have all that background and sort of then be able to bring it into, a company and organization that's doing some amazing things in that perspective. But as someone who's been doing this for much longer than many of us, like, what's your sort of perspective on how AI has evolved over that period of time that you've been working on it?
Yeah, absolutely. So, and as I said, I come very much from the AI systems perspective. Basically, how do you build computer systems that has AI components and turn that into useful and practical things? So that means I'm not a theoretical AI person by any means, but I'm observing the history there. So I'd say that AI had a few phases. I had the predictive models phase. There's also expert systems and so on early on, but I think, I'd say the practical one that's been part of applications for a while is making predictions with data, and then pattern recognition, and then there's a very strong, computer vision phase. Like, I don't know if people realize that we kind of got used to having computer vision in many forms, just being part of a day to day. We have smart cameras that can recognize objects. We have face recognition to authenticate things and so on. It started being just part of how we use computers very naturally. And then there was this Gen AI moment, that I think was, showing capabilities that, people found really surprising and useful. They're like, oh, it's amazing that computers can do this. And so we should thank, OpenAI and ChatGPT for showing this to the world in a very fast way. But a few things that I want to add, that's interesting to think about is that, all of this was made possible. Even the deep learning days when computer vision started getting a lot better, and then all this and this leading to generative AI focused models was this perfect confluence of a lot of data available to train models, a lot of compute power available by highly parallel compute engines in the form of GPUs or specialized computing entities, right? And also, better and better ways and easier ways for you to program all these things and run very large computational workloads, right? So if you think about the amount of compute required to train large, deep learning models a while ago, at that time was a lot of compute, right? So, but then only grew and grew faster than any other application class you can possibly think of, to the point that today we talk about GPU shortage, to train and deploy models because they use so much compute, right? So anyway, so see this confluence of data compute capabilities and ability to program them, and then techniques that fed the development of better and better models and algorithms was, I would say, some of the underpinnings of everything that we're seeing today.
Yeah, it's so fascinating. I don't think it's the first time that there's been this confluence of different factors. Like I'm not thinking of something off the top of my head, but it really is like almost things that I saw as independent trends. Probably you saw them converging because you were in the space, right? Like GPU and our ability to do sort of very specific types of compute.
Lots of data in the web because it was enabled by networks, right? So
like just really cheap storage. So let's just have more data. Like it got easier and easier to have more data. Things like MapReduce, which we kind of came and went, but like we don't need to have everything in a perfect schema and build a data warehouse. Like we can just put files in S3 and we'll sort it out later. So just this, we're collecting all the data, we're building the tools, we're building the compute to see it all come together and then really be able to, to realize it. And then ultimately, Gen AI, OpenAI, specifically like making it so easy to just try it. As someone who knows or knew next to nothing about AI when that launched, like, hey, I could type something into a chat box and I can see it working, right? Like, it just sparks the imagination, which then leads, I think, to another set of cycles of innovation, right? Because now you've got, oh no, this is totally possible, plus some creative mind from somewhere else saying, oh, if that's possible, then I can go do this thing. So
it was made more accessible, right? So basically,
exactly. I mean, like when was there ever an easier API than type any text you want and we'll give you back like a very interesting response, right?
I can offer a few thoughts there. Like one thing that I find interesting, by the way, is that this dream of programming computers with natural language has been around for a while. Just think of the evolution of programming languages that try to look more and more like natural language, but still being very structured. Never quite made it. And I would say that with these latest AI models, generative AI, natural language expression of tasks became possible, right? But there's one thing I want to add on this history here that I hope we don't forget to acknowledge here is that the reason they're possible too is because there's a lot of data available that was made because of the internet boom, the internet evolving so fast, having so much bandwidth now, and sensors everywhere. And that's what created the data, right? So first of all, there's of course a lot of text on the web, but mind you that a lot of the amazing things we're seeing today are multimodal. You can understand images and produce images. You can understand video and produce, visual content. And I would say that the next wave of evolution that we're going to see here is going to be by learning from this vast amount of visual and media data that we haven't really tapped nearly as much as we have into text. Some people claim that we basically trained on all the text that's generally available today. So the only next thing available is actually to go with other forms of data, right? This was all created because we had, the internet, we had sensors, and we had the bandwidth, the communication bandwidth to support this data moving around, right? So that makes a ton of sense. Like it's one thing to have cheap storage, but then we have to actually have stuff to store. And we've done all kinds of things to just make all that data available. And like, I mean, for certainly in the time of my career, like Web 2.0, if we remember that, was really like going from one-way production and broadcast and into interaction through the internet, right? Which created a whole bunch of additional data, right? Anyone could generate easily input, so you didn't have to be a technical person to write a blog and put that content out there. But now that content's been indexed and used to train models. We'll just gloss right over copyright issues and move on to the next thing. So
a big part of what you do is focus now on like optimization, right? So we just talked about people just getting the idea, oh, this is possible. What can I do? What's the next creative thing? But where does the optimization come into play? Like as people start to realize, oh, this is a thing I can do, but wait a second, it's slow, it's expensive, whatever that is. What's the piece of that puzzle that you're really interested in solving?
Yeah, absolutely. And this ties back to the comment about making more accessible for folks to use these models, but also making a lot more accessible for application builders to integrate AI capabilities into their applications, right? So I think we're at a moment now that there's enough maturity that you don't have to be a maturity in terms of model availability and systems. I'm going to tell you more in a second. Maturity of all that such that a general application developer can build with that without having to really understand how an AI model works and how the infrastructure works. So now optimization, why is this so important? It's because, these models that do all these amazing things, they use a crazy amount of compute, right? So, and they're very dependent on systems characteristics. Like, we're always pushing the limits of available compute on GPUs in the cloud. And now as things move to the edge on the local compute available, and programming that to actually get enough efficiency to make this viable, is very, very hard. So we need to build abstraction layers, right? So when does optimization come into play here? So more practically, what we're seeing very clearly today is that, there's quite a few developers and builders that now have experimented with AI, know what they want to do and add to their applications as they start prototyping it and they use, say, OpenAI, for example. And then they start coming against some limitations like latency, is the responsiveness good enough? The second, is the unit economics viable? Am I, if every interaction now costs 1,000 times more than it did when I did not have AI, it has to make you think like, how are you going to make this viable, or how are you going to rethink how to use it, right? And then there's practical questions also, how you make it reliable enough, because to how that we take for granted executing a prompt and getting the response back, but the amount of systems innovation that happens behind the scenes to get that back to you, coordinating a large number of GPUs and streaming the output and, managing all the compute required to do that is something that's amazing that it works as well, right? So optimization comes into play here in terms of making it faster, more responsive, making it the cost more manageable. Like we see clearly folks prototyping with OpenAI and then moving over to OctoAI, running an open source or, a customized open source model in our fully managed platform. And they get, better performance, really, industry enterprise grade reliability, and also much lower costs by at least an order of magnitude. And that comes because we optimize a lot of the turning the machine learning model into very efficient code, but also you don't have to worry about which GPU to run it on, which cloud to run it on. We abstract all of that away and turn that into a highly efficient system that's completely transparent to the builder, right? So,
yeah, I mean, I like my favorite part of that is abstract all of that away, right? Like yes, this is a hard problem that you will face as a application builder, right? You had your imagination sparked, you went and pursued an idea. Now you're like, oh dear, how do I pay for this, right? The capability,
how do you make it viable in a number of ways, right? Yeah,
right. So there are solutions out there that are not. Now you become an expert in tuning and like GPUs and whatever. Just like some of it is free, or done for you, right? I guess I always air quote free.
There's a lot of options today. Yeah, and there's a lot of options today, right? So I hope I'm not randomizing the conversation here, but it's always fun to just go. Like one of the things that I find interesting is that there's so much progress in open source models that builders can control. That now you don't have to be dependent with a big, proprietary model provider that's the same monolithic and so on. You can actually bring it over, have more control, and now you can also have abstraction layers in the systems to just go and do that without having to really understand details of the model and where to run it on. I mean, that's what I find is that we are offering and some other players are offering too, is this ability of showing that, hey, you can easily move workloads from, say, OpenAI to an open source based model, but also you can go and tune this model to have, the behavior that you expect. Sometimes you get quality might be even better than what you'd get from a proprietary model. And you can still do all of that without having to understand system details, right? So there's a large number of GPUs that you can run things on. Navigating price performance there is hard. Navigating capacity, acquiring capacity is hard. So, anyways, there's one thing that I was writing about on LinkedIn today. I don't know if you remember the cap theorem, in systems. Yeah. So an equivalent of that, but for, AI systems, which is balancing, cost efficiency, inferencing speed, and availability / capacity. Like you can actually trade off these things very clearly. Like you can have really high inferencing speeds by throwing a lot of GPUs, making cost worse and reducing your capacity, but you can have a really great speed. Or you can choose to do extreme cost efficiency and have much lower speed and then have more capacity because you can sustain more loads. And there's many optimizations techniques that you can get more, more performance, but actually at a much lower efficiency, meaning that your capacity goes down quite a bit. So, navigating these is something that's critical in any real deployment. And that's something that I firmly believe the system should do for any builder. But that's not the reality today, and that's what we're working on. What we offer here is the ability to navigate these system parameters automatically for you.
What I think is really fascinating about that is just the pure engineer. Like my hands are shaping a triangle by accident, which is just like, this is my cap theorem.
Yeah.
But the engineering discipline behind what we often refer to as computer science, right? Like I think when you and we maybe talked about this the first time we met, but like in the sort of pure science world, right? You're learning foundational techniques or whatever. Like given a code editor, I can build anything, right? But you just use the like words in the real world, right? Things cost money.
Yeah. Things need to be reliable.
And I need to make a decision about what matters to my customers. Is it the inferencing speed? Is it the cost? Is it, what is it, the availability, right? Like, and we make those kinds of decisions all the time in, I'll call it software. I'm trying to avoid science engineering, but like, in our jobs, that's what we do, right? We make those sorts of trade-offs. We make trade-offs about availability and reliability of systems because it costs more money to be more reliable, and what's the right point, what's appropriate for the business that I'm running. And that depends, right? Like you can't make that decision, right? As OctoAI, you can't make that decision for every business about what matters, but you can make it possible to make the choice and help the customer understand, here are the kinds of trade-offs you would be making. This is going to cost this much. This is going to cost this much. Here's what you can expect from us.
Or do even better, right? So, and I would say that I completely agree with that. But I would say there's one more, there's a plus to that, which is, telling us what the SLA is, what matters to you. Do you care more about latency? Do you care more about throughput? You care more about cost? You care more about availability? And we give us the SLA and we navigate all of the systems components for you to hit that SLA within those bounds automatically. So give the input of what you want it to be as opposed to how you get there, right?
Right. Exactly. This is my expectation and this is my, this is what I'm willing to pay. Maybe I have to change one of those even, right? But that's what matters to me is sort of like latency and cost, right? Are the thing as a consumer. And then how you make that happen, I want that to be abstracted away. I don't want to be an expert in that system, but I want to understand what the impacts are for the decision that I'm making. And I think that like we underestimate maybe as a community how much of that work we do, like that sort of engineering work. We've been thinking a lot at CircleCI and I've been talking to a lot of folks who are thinking about this, about like non-deterministic testing. Right? Results in generative AI. Like we used to live in a world where the answer was right or it was wrong. And now we live in a world of gradients, right? Like it's good enough. It's close enough. Yeah. When do we say it's not good enough? Like, and that feels uncomfortable, yet we make statistical decisions on all kinds of things in our work
all the time,
every day, right? Like how much am I willing to spend? What's the reliability? Is it good enough if it's 98% up? If it responds within X time, 99.7% of the time, like that's actually how we do a huge amount of our work. And so it's, I think it's like more core to what we do than I think most of us talk about.
Yeah, absolutely. And I love that thought. And that's something that I hope it's not too academic to think about this, but I feel like to think this way, but I feel like we do this with systems of humans all the time. Like when you have a process that has an automated component and you have some humans in the loop, implicitly we are building like, okay, so you're going to send this person, you have to go check the output. Like when you string humans together to accomplish a task, you always have these things built in how you build your processes, right? So, but now if you think that these AI models are actually now doing things that only humans were doing just a couple of years ago, it's only not, I mean, why is it surprising that we have to go and also think about some of these ways of managing the malleability of the output and baking that into how you build a system, right? And I think it's just natural to go there. There's whole disciplines on how you build reliable systems out of unreliable components, and now we're doing this in a broader scale, in a much more principled way. One thing I wanted to add to that, in addition to thinking about what we talked about, like latency, cost, and capacity, availability, reliability, there's also other components that relate to some of this, like how do you monitor quality to make sure that they are within some quality bounds? How you do that in an automated way that doesn't rely on a large number of humans online trying to go and moderate things, right? And then how do you deal with aspects that you need to think about on trust and safety? How do you layer that in as part of a system component here that we haven't been building with before, right? So that's just really fascinating to think about, and I'm glad that there's a lot of people thinking about it, because there's just so much value that's shown that can be built around this, right?
Well, so one of the more interesting insights that I've had, because someone explained it to me, was that you're already collecting the data from humans, right? Like, and again, things we've done, right? Like we do behavioral analytics on a website. Where do people go? What do they click on? When do they leave? Right? So we're already measuring, even in fixed text that we wrote, how are people responding? We do A/B tests, and we do this at CircleCI, but we as a software developer, like, do they click through this better than this, right? So when you're getting, for example, generated, AI responses, when the user says, like, they type their same question again, or when their tone increases in terms of their next prompt, right, to like, I am frustrated, why are you not actually answering my question? You have a huge amount of data to be able to say, oh, this is not doing the job that we wanted it to do, right? Or when people just leave, right? Bounce rate, like super classic measures that we've always used. If everyone's looking at the responses from your generative AI and they're leaving, you're not getting the right responses. Like, you can measure that, pretty easily without asking
and feed that back,
an individual, please go look at this response and see if it's like, you're already collecting all the data, or ideally you're already collecting all the data if you collect that kind of data at all. And so, I was also thinking about, oh my goodness, I've forgotten the name now, so it's really sad, but like the prompt to confirm that you're a human in all the forms that we all fill out, right? Yeah, reCAPTCHA. Thank you. Yeah,
reCAPTCHA,
and the use of that, like, please identify which of these pictures has a stoplight, right? Like, we're training image analysis when we're doing that, right? But none of us knew it. We were just like, oh, I guess I can prove that I'm a human, but we're actually like, they also didn't know which ones had stoplights. Because they go and mix a random
mix of what's ground truth versus to make sure you're doing the right thing versus the other ones, right? Yeah,
right, exactly. Like, we have access to humans who will happily click on the buttons and like do the work for us, as long as there's something in it for them, right? So the data's all out there, and it doesn't have to be this like really clunky experience, I guess is what I'm trying to say.
On that note, one of the things that I find really, I completely agree. There's a lot of implicit data they can build from and get, and then make the system better. There's also engineering aspects that I feel like fascinating to think about, how you think about prompt engineering versus software engineering. I don't know if you've heard this, like if you add please to some prompts, you actually get substantially better response, because when you add please, you go into some corner of the latent space to generate the next string of words that tends to be better. Or if you add, some keywords that say, the name of a conference, or say copyright, and you're like copyrighted, that means that now you're actually going to other documents that tend to be higher quality than just a bunch of documents that are not, right? So, it's interesting to think that even though it feels like we're talking to these models, all you're giving it is giving input. So this corner of the space super high dimensional space that's really hard to imagine, because we always think in 3 dimensions typically, right? So, but that's a corner of the space that's finding, what are things that are the components that feeds into the generating the output that you're expecting. And every single, token matters here. And then one token could make a huge difference. And, so there's
it's
interesting to think about this.
It's absolutely a funny thing to think about. Like, my experience is limited, but we actually just did a course, like an intro course on building testing and stuff. And I was working through the exercises myself, and I felt like I was like screaming at the LLM, like, no, like, what is it going to take for me to express this in a way that you will actually understand what I mean? Right. And it's like, we always joke that it's sort of like dealing with toddlers in a way, you know? Like, if I use different language, if I put this in all caps, if I say please, like, what is it that's going to get you to do the thing that I want? And then, we'll say stuff like, and make it interesting. And then they just, complete hallucinations. Like, now I can just make up whatever I want,
Yeah. And it's interesting that now you can actually, deal with a lot of this too by adding more models to the mix, right? So we see very clearly, our folks building applications on our platform, building with model cocktails that, use a string of multiple models together to build a certain functionality, where some models are there to evaluate quality, other models are there to improve the prompt, other models are there to actually determine which one is the best one to show to the user. Like, this is, the way you're now thinking about these AI models as modules that you can string together into a composed unit and have better and better behavior by engineering that is really cool to see how fast that's advancing. So,
yeah, I love that notion. It feels like that's going to be a big area of progress over the next 12 months. Like, as we take this, again, we've discovered that there's a lot of possibility, but now we're trying to get it to the place where it actually solves customer problems, right? Like, we're building capabilities into products and trying to solve this. And it's like, oh, wait, if someone mistypes one word, like, the whole thing goes sideways. How do we protect ourselves from that, right?
Yeah, right.
Because it's not just this one, you have one choice, this foundation model, it's the only one there. It's like all these things have slightly different characteristics and behaviors. And if you mix them together in just the right way, I love that you used cocktail for that. I'm like, it's like a mixology experiment, right? Like it's just the right ratio of like citrus to whatever. And then I'm going to get the answer that I want. It's going to be awesome.
Well, and to that point, to take that analogy further, one of our board members, Matt McElwain, long time friend and advisor too, and mentor, has talks a lot about model cocktails. And one analogy that I was, helping build on with him was, the ratios too. Like, you could say you have the base liquid, which would be the open source model that you control, you call most of the time. And then you have some sparing use of, say, the bitters that can change the composition quite a bit, but you call much more sparingly. I feel like that's where the frontier model calls are going. Like, you couldn't call GPT-4 all the time because you're not going to get what you want, and also it'll be too expensive anyways. But what you add just a little bit. So the way you're doing this to manage quality, but also to manage costs and to manage dependence on external entities by calling sparingly, some of these frontier models is an interesting trend. And now blending other components like vector databases in the context of retrieval augmented generation, where, they're doing similarity search, right? So finding things that are similar to the inputs to help you produce inputs to the flow. To the rest of the application flow is also another component of this cocktail that I think is becoming an integral part of the whole thing. So, yeah.
Yeah. All right, folks. Well, maybe you heard it here first. Hopefully you did. Like, now it's about blending the pieces, right? If you can't get the perfect behavior, don't just fight with that one. Sprinkle in a little bit of another, and you'll get the exact flavor.
You can even fix bad compositions. How many times have you fixed a dish or a cocktail by adding more things as opposed to starting from scratch?
Yeah.
Right. So.
Yeah. Love it. Awesome. Amazing insight. Well, thank you so much for joining me. And thanks to everyone who's listening. If there's anyone you want us to talk to, anything you want us to talk about, find us on Twitter at CircleCI. And if you enjoy this podcast, share it with all your friends. Subscribe on your podcast provider of choice. Yeah. Luis, thanks again so much.
Thank you. Thanks for having me on the show. And everyone, come to OctoAI, see what we have there, start building. There's a lot of great stuff for you to build with there. So
yes.
Thank you.
In this space in general, just start building. I keep saying it, just try it. There's so much to learn, and it's always fun to get your hands on stuff and just get going. Awesome. Well, thanks again.
All right. Thank you.
If you like what you heard today and want to learn more about building, testing, and delivering AI-enabled software, we've gathered all our best resources and tutorials into one place, Go to circleci.com/AI-ML to explore and start learning.